Okay, so now we're going to start graphing these guys. Just to save us a little bit of time on the videos, I already pre-graphed in the parent functions of this because it says graph the parent function and then like see what this is actually doing. All right, so with these, you can, if you automatically know what your parent function is, you can graph your parent function and then you can just ask yourself, it's like, which way is this guy shifting this? And then you can just go from every point and go whichever way that it's telling you to go. One of the ways that I like doing this is I always like referring back to my parent table. So our parent table for quadratics was -2, -1, 0, 1, 2, which means my y's were 4, 1, 0, 1, 4. All right, that's my parent function. That's where I'm always going to start. So if you guys want to, there's going to be 3 parent tables. So if you guys just want to like highlight this one's for quadratics. Okay, so now we have to go over here and we have to ask ourselves what's going to happen or what's happening to this graph. So we look inside here, is this an A, H, or K? We know that if it's stuck inside with the X, that means it has to be H. We also know that H shifts left or right. So if I'm subtracting 2, it seems like I'm shifting left, but remember, everything that happens inside the parentheses is always opposite. So this guy is actually shifting right 2, okay? And that's because what I was trying to tell you before, in our original, if I just have this, in our original like function over here, everything is getting subtracted inside here, and that's what makes it go the opposite way. So over here, H is actually a +2. That's why it's shifting right 2. And this is what I like doing to my table, and it just makes it really easy for me to graph. If I'm shifting it right 2, that means I'm adding 2 to my X values. All right, so if I go over here, I'm going to add 2 to each and every one of my X values. So when I add 2 over here, -2 plus 2 is 0, -1 plus 2 is 1, 0 plus 2 is 2, 1 plus 2 is 3, 2 plus 2 is 4. And then these guys, I am not even going to worry about those. Those X's are gone. So now when I go to graph my transformation graph, now I am plotting the points 0, 4, 1, 1, 2, 0, okay, because the y values didn't change. I'm just changing the x's, so it should look like it just got shifted right. So 0, 4, 1, 1, which is still over that dot, 2, 0, 3, or, oops, that wasn't 2. Sorry. Oh, that was my -1, 1, sorry, 2, 0, and then 3, 1, and then 4, 4. All right, so there's my transformed graph. And again, without my mistake, it should look like every single point got shifted to the right 2. All right, let's deal with this graph now. So we're still in quadratic, so I still have my parent function or graph over here. So -2, -1, 0, 1, 2, then square everything. Okay, now I have to ask myself, okay, what's going on with this function now? So my g of x, it's adding 3. So this is not in parentheses. The 3 is not getting squared with the x. So this is on the outside, and it's adding or subtracting. So that means that this is k. And again, k is just, k's don't lie to you. K's are just that regular positive 3s. So k shifts up and down. So this graph is going to shift up 3, which means I'm going to be adding. So if you think about shifting up and down, you should be thinking about your y-axis. You're shifting up and down on your y-axis. Over here, if you're shifting left and right, that means you're shifting or changing your x values if you're shifting left and right. So this means I'm going to be adding 3 to my y values. So now my x values get to stay alone, and now I'm going to add 3 to all of my y values. So 4 plus 3 is 7, 4, 3, 4, 7. And then again, I can just get rid of those guys over here. So now I'm plotting the points -2, 7. So -2, 1, 2, 3, 4, 5, 6, 7. -1, 4. And then I have 0, 3, because everything's getting shifted up 3. 1, 4. And then 2, 7. Again, if you really wanted to, if you started with your parent graph over here and you just like took your vertex and shifted it up 3 and then took this point, shifted it up 3, that's also fine too. I just feel like this way gives you like a little bit like, what are you actually doing? Why is this changing it? Okay. This one we'll just skip to save time because it's pretty much the exact same thing. I'll just do it the shortcut way. This is K, and K is -2, which means it's shifting down 2. So I'll just do it over here. So I'm taking this point, shifting it down 2, this point, down 2, this point, down 2, down 2, and down 2. So your Ks are just shifting these guys up and down. All right, let's go on to the next ones. Okay, now we finally get on to square root functions. So when you have just f of x equals the square root of x, obviously I can't do my normal x values of -2, -1, 0, 1, 2, because 1, I can't take the square root of negative numbers. Those are imaginary and I can't graph them. And 2, -2 or 2 even, is not a perfect square. So that's why they chose these numbers for you. 0 is the lowest number that you can take a perfect square of, and then it goes to 1, 4, 9, because those are our perfect squares. So this is my parent table. And then all we're doing is plugging in these numbers in for x. So the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So again, I'm just going to highlight this just for you to like reference back to. So this is going to be my parent table for square root functions. So let's graph and see what this looks like. So I have 0, 0, 1, 1, 4, 2, 1, 2, oops, 1, 2, and then 9, 3. And again, I know I'm probably graphing too fast for you, so just pause whenever I go really fast. Okay, then over here, this guy is an A. A's are going to affect my y values, but in this case, let's just like see what's going to happen. So if I have negative the square root of 0, then I just have -0, which is just 0. If I have negative square root of 1, I have to take the square root of 1 first, and then I'm going to multiply it by the -1. So 1 times -1, -1. So you see kind of what's happening here. It's just turning everything negative. So the square root of 4 is 2 times -1, -2. Square root of 9 is 3 times -1 is -3. So when I go to graph that, 0, 0, obviously on the same point, but now I have 1, -1, 4, -2, and 9, -3. Okay, so now this looks like a sideways parabola, but it's really two different graphs, so keep that in mind. So remember, a negative A makes it reflect over x-axis. Okay, so whenever you have a negative, you're pretty much just making these guys negative, unless you actually have, like, if you had a -2 square root of x, that's going to do something different. We'll talk about that in a second. All right, so we are back to our quadratics over here. So I'm going to do our parent table. So -2, -1, 0, 1, 2, 4, 1, 0, 1, 4. And again, we have this negative a value. So remember, so negative a affects the y's, okay? But you'll notice how it's not getting added or subtracted, it's actually getting multiplied. So whenever you have an a value, you're actually multiplying the y's by whatever that is. You're multiplying these y's by -1. So now I'm going to have -4, -1, 0, -1, -4. And then I don't have to graph these guys. So when I go to graph this guy over here, I have -2, -4, -1, -1, 0, 0. And then I can just reflect these really fast. So those negatives just turn my parabola upside down. All right, turns my smile into a frown because they're negative. Okay, let's keep going. Let's go on to some Absolute value functions. Okay, so absolute value functions, they're not giving you a parent table. I'm going to give you the parent table. So with absolute value functions, we can start plugging in negatives again, because hopefully you guys remember what's the absolute value of -2? Everything comes out positive, so it's just going to be +2. So I can still use these guys for my parent table. So let's just think about this. If I just had y equals the absolute value of x, because this is my parent table, if I plug in the absolute value of -2, everything comes out positive. So nothing's happening to it, it's just turning positive. Absolute value of -1 is just 1. Absolute value of 0, you just get 0. And then all of these, it doesn't change the sign, everything just comes out positive. So this guy is your parent graph for absolute value functions. So I'm going to graph this parent graph. And these guys are really easy because they just look like V's. And I always say V for value. So parabolas are U's, absolute values are straight V's. Okay, so now let's actually see what's going on over here. So it looks like I have something inside with the X. So this is going to be my H. And remember, H is always the opposite of what it seems. So it looks like I'm adding 2, but I'm actually subtracting a -2 according to my original function. All right. So my H is -2. H's affect the X values. So that means I am subtracting 2 from all of my X values. And then I have a number on the outside over here. These are my K's, and my K's don't lie to me. So I am still subtracting 3 to all of my Y's. Now, be careful over here. So you are subtracting 2. So it does matter which order you go into. You're always taking your X value and then you're subtracting 2. So -2 minus 2 is -4. -1 minus 2 is -3. 0 minus 2 is -2. 1 minus 2 is -1. And 2 minus 2 is just 0. Over here, I'm going to be subtracting 3. So I have to do 2 minus 3. So 2 minus 3 is -1. I'm going to do it on this one. 1 minus 3 is -2. 0 minus 3 is -3. 1 minus 3 is -2. And 2 minus 3 is -1. All right, so let's graph this guy. So remember, all of this inside here is now gone. When I'm graphing these values, now my points become, I'm graphing -4, -1. So -4, -1. -3, -2. Okay, sorry. All right, -2, -3. And then I have -1, -2. And then 0, -1. Again, these are just straight V's because they're absolute value. Okay, and now it should look like the graph got, because the H shifted it to the left too. So it does look like it got shifted to the left too. Every point got shifted to the left too, but this K makes it shift down 3. All right, so every point got shifted left 2 and down 3. All right, let's do this one over here. So pretty much the same idea. So I'm going to start with my parent function. And again, if you know that this is your parent table and or parent graph, and you just want to go left 2, down 3, and just plot your points that way, that's fine too. So -2, -1, 0, 1, 2, and then I have 2, 1, 0, 1, 2. Same thing over here. I got my H. And again, my H is always opposite, so my H is actually +3, so I'm going to be adding 3 to my X's. And then my K is +1, so I'm going to be adding 1 to my Y's. Oops, I meant to make that pink, but it doesn't matter. All right, so over here, and again, always start with these guys. So -2 plus 3 is going to be 1. -1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. And then these are gone. Don't need to do those anymore. 2 plus 1 is 3. 1 plus 1 is 2. 0 plus 1 is 1. And then 2, 3. And then those are gone. So now I know I'm not graphing my parent graph, but that's okay unless you want to graph your parent graph and just move it like that. It's up to you. So now I'm going to plot these points. So 1, 3, 2, 2. So 1, 3, 2, 2, 3, 1. And then I have 4, 2, and 5, 3. And again, I always you can always double check from just like your parent vertex point, which is always on the origin. Does it look like I shifted up 1 into the right 3? So up 1 to the right 3. It does look like I did that. So I know that I'm going to be correct over here. Okay. One more. Okay, so now we are back to our parabola. So you always have to make sure you're checking and seeing which parent table that you should be using over here. So I'm still going to be using my -2, -1, 0, 1, 2. And then since this is quadratics, that means I'm squaring everything for my parent table. Okay, so now let's see what we got going on over here. We have an A that is a -1. A's affect your y values and they affect them by multiplying by them. Then we have a k over here because again, this 5 is not in parentheses or it's not doing whatever the x is doing, it's outside. So my k is 5. My A's and K's both affect my Y values. So nothing's happening to these X values. They get to be left alone this time. But now you have to ask yourself, which one should I do first? Should I multiply by -1 first or add the 5? And it's just like order of operations. The first thing you're going to do is multiply by that -1. Then you can go in and add the 5. So what should be happening over here? I'm just going to write it down here. I'll write it over here. What should be happening? That A that's negative is going to make this graph reflect over x-axis. And then that K is going to actually shift it up. Okay, so when I graph this, I should see my original function getting shifted up 5 and getting reflected over the x-axis, which makes it turn upside down. So when I multiply each of these by -1, they just all turn negative. And then I'm done with these. I'm not going to graph those anymore. And now I'm going to take these values and add the 5. So I'm going to have -4 plus 5, which is 1, -1 plus 5, which is 4, 0 plus 5, which is 5, -1 plus 5, 4, -4 plus 5 is 1. And then that means I don't need these values anymore. So what am I actually graphing? I'm graphing the points -2, 1, -1, 4, and so on. So -2, 1, -1, 1, 2, 3, 4, 0, 5, 1, 4, and then 2, 1. Okay, so again, this graph didn't get shifted left or right at all. So my vertex is still on the y-axis, but now it did get shifted up 5 and now it's upside down. So that is what had to happen over here. Okay, that's it for this video. Piecewise are next, and those are everybody's favorites. So make sure you are watching that video.